Hey guys, Travis here. Sorry that I haven't been uploading videos like I said I was going to. I'm a little behind. I'm going to see if I can catch up and start uploading one every other day. So let's go ahead and get started, guys. So here are the notes. They're pretty short, they're pretty quick, and they're pretty simple. They're just like the last one, so it's a continuation. So hopefully we'll get this one without any errors because the last one had errors. So I have a vector. Vector, you have the magnitude of 3 and the direction is 235 degrees. If vector v equals 4u, then what is the magnitude of the direction of vector v? Alright, so I have a vector u with a magnitude of 3 at 235 degrees. So that's going to be something like in quadrant 3 with a magnitude of 3. So I have something like this. So I'm going to write u, let me put red here. U equals 3 and then cosine 235 degrees, comma, sine 235 degrees. That's going to give me my magnitude of the x component and the y component. And I'm going to multiply that by 4. So v is, what is 3 times 4? 12. So 12, and then it's still going to be cosine 235 degrees, sine 235 degrees. So here's how the vector u looked. I should put a hat on it, right? There's my hat. Vector u looks something like, let's see. Well, I'm just going to go ahead and just draw it here, guys. Vector u, 3 cosine 235. Well, okay, I'll just make it quick because I don't think delta mass really cares too much. So I'm going to say this is 3 at 235 degrees. And then if I want a magnitude of 12, then I'm just going to do this vector times 4, right? So I would be like having 4 of those arrows. So it'll probably look something like, and at the same angle, 235 degrees, where this magnitude is 12. So hopefully that made sense, guys. Let's see. Well, then what is the magnitude and direction of vector v? Well, the magnitude is 12, and the direction is 235 degrees. I hope that made sense. I don't see anything else. I don't see anything tricky there, guys. Unless I'd misunderstood. No, everything looks pretty straightforward. All right, vector u has the magnitude 3 and direction 140 degrees. Okay, so this is gonna change because I see a negative there. If vector v is negative 2u, then what is the magnitude of direction of vector v? All right, so 3 at 140 degrees. So I look something like this. It's not accurate. 140 degrees is somewhere in quadrant 2. So I'm going to say here's 3. And here's my angle at 140 degrees. Now, this is negative 2, guys. So because it says negative 2, that means opposite. So 3 times negative 2 is negative 6. So I'm going to go like this. Negative 6. So this magnitude is 6. And the angle, I guess you could either say it's that angle there or it's this angle here. That would be negative. I think the delta mass has it between 0 and 360. So what you're going to do, you're going to take that 140 and you're going to add 180 to it. So 140 degrees plus 180 and you get, not that I need a calculator here, but you get 320 degrees. And there it is, guys. So what's the magnitude? The magnitude is 6. How do we get 6? Because of that 2. 3 times 2 was 6 there. And what's the direction? The direction is 320 degrees. I hope that made sense. I don't think this vector is super accurate. Like I don't think it terminates right there. But this is just like a glimpse to you so you guys can see how it works more or less. And then really that's how simple it is, guys. So the magnitude is 6. And they'll probably have something like this, double parentheses, like absolute value with a V and a little hat. And you're going to say that's 6 like that. And then what's the direction? The direction is 320 degrees. All right. Very cool, guys. Let's go to the next one. Ooh, this one. All right. So this one, I'm going to go ahead and also make a video on. I'm going to show you how it's going to look on delta math. So it says given vector u with a magnitude of 8 and direction 210 and vector v with magnitude 4 and direction 30, find the magnitude and direction of the sum u plus v. Write the sum u plus v in magnitude and direction form with magnitude rounded to the nearest tenth and the direction rounded to the nearest degree. All right, I'm going to break these up into x and y components, guys. So I'm going to say vector u in the x direction is nothing more, and you've done this in physics already, guys. So the magnitude is 8 and the direction is 210. So 8 cosine 210 degrees. And when I type that into my calculator, 8 cosine 210 degrees, I get negative 6.9282. And then vector u, there's my little hat in the y direction, 8 sine 210 degrees. And I believe, what's 210? Like half or something? Sine of 210 is negative half. 80, 9, 10, 18, 19, 21. Yeah, it is. So you're going to get negative 4. I'm doing this from the unit circle, guys. So there it is. This is my x and y component. So I'm going to write vector u is my x component, negative 6.9282, comma, my y component, negative 4. All right, now I'm going to do vector v. And I'm going to see if I can use a different color here. So vector v, the x component of vector v, is, let's see, 4 direction 30. So 4 cosine 30 degrees. So I'm going to get 4 cosine 30 degrees. I know that cosine 30 is square root of 3 over 2, guys. But I'm doing this in decimal because it says nearest tenth. So 3.4641. And then v in the y, that's just 4 sine 30. And that's going to be, sine 30 is a half, so it's going to be 2. All right, so my vector v in component form is 3.4641, comma 2. So what does that mean? Here's how that vector looks like then. So this vector here, let's see, it terminates negative 6.92, negative 4. So from the origin, negative 6.92, I'm going to say it's like right there, negative 6.92, negative 4. I'm going to say like right that dot. So that magnitude is 8. And then let me go ahead and color code the blue one here. So let's see, 3.46, comma 2. So 3.46, comma 2, I'm going to say it's like that guy. And I want you to notice something. Look at that red and blue line. Notice that together they form a linear pair. There is, between these two, that is 180 degrees, guys. So, and how do I know it's 180 degrees? Because this one is, what was that, 210, and then this one here is 30 degrees. So 210 minus 30 is 180. So I want you guys to see. So imagine the red line and the blue line just on the x-axis. If I want the magnitude of that, well, this one is 8, and this blue line here is 4. So then that means overall the magnitude is going to be 4, magnitude. If I were right on the x-axis, then I would say negative 4, because this arrow would be right here. That's like if these were forces. If this were a force 8 to the left, and this is a 4 to the right, well, then the net force is 4 to the left. I hope that makes sense, guys. I really hope that makes sense to you guys. All right. So they want to know the resultant vector. So obviously the resultant vector has a magnitude of 4, and it's going to be in quadrant 3, just with the rules that we just said. But if we want to know, we just do this. I'm going to go, I'm going to choose a neutral color like green. I'm going to go u hat plus v hat equals, and I'm just going to add the x components together. And then I'm going to add the y components together. So negative 6.9282 plus 3.4641. That's going to get you a negative 3.4641. It should not be a surprise there. And then negative 4 plus 2, and that's going to give you a negative 2. So u plus v, I'm going to get negative 3.4641, comma, negative 2. That's my resultant vector when I add these two suckers up. And it's going to look something like, let me see, negative 3.4, negative 2. I didn't do it perfect, guys, but it should be something like that. And you can see that, yeah, it makes sense. Hopefully all this is making sense to you guys. I hope. So let me go ahead and show you how it's going to look on Delta Math, and I think you guys will understand a lot greater. So let me do that right now. All right, one more thing, guys, I forgot to mention. So they want the, let's see, it says here, write the sum and magnitude. So the magnitude of, how do you find the magnitude of anything? I'm going to go ahead and write it in black. So to find the magnitude, you're going to have to square those values. Now, in this case, it's easy to see, guys. It's going to be a 4. But in case it's not for other functions, here's how you find the magnitude. So magnitude is going to be equal to the square root, and it's just like Pythagorean theorem, negative 3.4641, close it squared, plus negative 2 squared, and you're going to get 4, obviously. So that's how you get your magnitude. And then the direction, you don't have to do it on this one because we already know, we can already see that this one is going to be at 210 degrees. But if we wanted to do it, it would go arctan of y divided by x, so negative 2 divided by negative 3.4641. Now remember, the calculator is dumb. Negative divided by negative is a positive, and you're going to get a positive 30 degrees. Now, to get the 1 in quadrant 3, you add 180. So when you add 180, you're going to get your 210 degrees. So there it is. So how do you write it with magnitude and direction? Like this. Sorry that down here is because I'm stating this after the fact, guys. So I'm writing another video here and putting it in. So you write 4, and then the direction is 210. Sometimes we write 4 cosine 210, 4 sine 210, but Delta Math has been writing it like this. So 4 chevron cosine 210, comma, oh, don't put the 4 in there because then that's like 16. And then sine 210. And there it is. And that's it. All right, guys. I hope everything made sense. And let me know if something didn't make sense. All right, later. All right, guys. Here we go. Here's that same question that we just did a little while ago. I just wanted to show you how it looks in Delta Math. It's a little funky, and I did this one specifically because 30 degrees and 210 degrees are opposite of each other. Or if you add 180 degrees to the 30, you're at 210. And so the numbers work out pretty nice. So let's go ahead and do this. It says plot the two vectors by clicking and dragging from the origin. So we already did, so let's see, 8 at 210 degrees. That's at quadrant 3, and then magnitude 8. So it tells me the magnitude of the vector there, and 8, and I want it at 210 degrees. So 210. Now I gotta stretch it. There we go, 210. It's easier if you have a mouse, guys. Yeah. Now plot vector v by dragging from the origin. So V is 4 at 30 degrees. So let's see, 30 degrees right there. That's 5. That's 4.5. Now I'm at, come on, buddy. There you go, 4 at 30 degrees. It says drag one of the vectors in order to add U plus V. So as you can see, U and V, guys, are opposite of each other. Here's U at 4. Here's V at 210 degrees. So you can already see when you add them, you're going to be in quadrant 3 because vector V is way larger than vector U. And look, it just forms a straight line here. So I'm going to add them. So I'm going to put that tail where that head is right there. And the difference from the origin to here, that's your resultant vector. So it says now draw the U plus V by clicking and dragging from the origin. I go to the origin. This dashed line was your vector U, guys, or the V, sorry. So here we go. And that in orange is your resultant. So there it is. And they want me to write my components, y's, your x and y component. And we did that earlier. So negative 6.9282, I believe, is what we got there. Oops, that doesn't say that. Let me put a dot there. Negative 6.9282, negative 4, 3.4641, which is actually half of 6.9282. The magnitude, at least, not the with the sign. And then 2 is half of 4 magnitude-wise. And I push try, and it worked. And it says U plus V, and that's when we add them. And there should be no mistake of why you get negative 3.4641 again. But negative, right? Negative 3.4641, because that's half of 6.92. And then half of 4 is 2, but I'm going to be in the negative direction, so negative 2. You click try. And then U plus B to the nearest 10th, that's when you do the Pythagorean theorem. And you get a perfect 4, but that should not be a surprise, guys, because think about it, the magnitude was 8, and then the other magnitude was 4, and then 8 minus 4 is 4. So try, and there it is. And then to the nearest angle, well, we already know that that angle is 210 degrees, so 210. And it says, now convert U plus V into magnitude plus direction. So the magnitude was 4, and my angle was 210, so 210, 210. And there you go, guys. So I hope that made sense to you guys. And yeah, all right. Talk to you guys later. Bye. Or, okay, not talk to you guys later. We're going to continue. All right, later. All right, guys, here we go. Last one. So it says, given vector U is 1, negative 6, and vector V is 6, negative 8, find the difference, v minus u, and represent the difference graphically in two different ways. All right, so let's do it one way. So they want v minus u. So let's go ahead and first say what vector is what. So u is 1, 6. So let's see, 1, negative 6. So 1, negative 6 point, and so that's u. It's not perfect, but there we go. So that's vector u there. And vector v, I'm going to put vector v in blue here. So blue and red. 6, negative 8. So 6, negative 8. Oh, that's not blue. There we go. And come on, buddy. Work with me here. There we go. All right. So remember, one way to add these up, guys, or I guess it says subtract. So one way to add these up, you can say v plus a negative u hat here, or vector u. So this vector here is your v. And opposite of u, let's see what opposite of u is. I'm going to go back to red, guys. Opposite of u just means go the opposite direction. So that means negative 1, 6 point. And I guess maybe I should use, okay, I'll use a dotted line. That didn't come out very good because the precision on my, there's something off with the calibration of it. I guess I got to go to the Microsoft store. Yeah, because it's not perfect. That's fine. We'll just work with it. All right. So there it is. There's opposite of u. So I'm going to call that negative u. So how do you add? Well, head to tail, head to tail. So when you add v plus that negative u, you slide this guy. Let me see if I'm able to slide it. Right. Well, it was supposed to slide the whole thing there, but it didn't work there. All right, so there it is. So what is my resultant vector? My resultant vector is this guy right here. That's my resultant vector. So that's method 1. So method 2, I want you to notice, and you're going to start at the u one. So from u to v, if I connect those two, that should be the same vector as this one. See, those are the same vectors. So that's how you can add it, guys. You can either do head to tail, or I guess from vector v, and then the head of that one, you add the tail of u, the negative u. Or what you can do is, since it's v plus a negative u, you can start, here's your u vector. You can say, if it's v minus u, you can start at u and then connect that head to the head of v, like we did here. So those are my second way. That's my first way. There's my second way. And it's going to ask you that on Delta Math. It's going to guide you through that, guys. So hopefully that won't be too extreme for you guys. So you can see already that this vector needs to be, what is that? 5, negative 2. So let's see if that's the case. Vector v was 6, 8. So remember, how do we add vectors? We just add component-wise. So 6 minus 1 is 5. Perfect. And then negative 8 minus a negative 6, you're going to get negative 2, right? Because negative times a negative is a positive. So it's like negative 8 plus 6. And yeah, it works. That vector definitely is 5, negative 2. Yay. All right, guys. I hope everything made sense. I'm going to upload this, and let's get rolling. There's a Delta Math activity. It's pretty simple. And then hopefully the next activity, we got one more Delta Math activity, and then we'll get a handout going. So we'll do a handout through Google Classroom. I hope you enjoyed this video, guys. Give me a thumbs up. I guess you can give me a thumbs down if you want, but I'd prefer a thumbs up. All right, guys. Talk to you guys later. Bye.